Chances are good that your idea of speed is exactly what you think it is. And you probably think that velocity and speed are the same thing. They are close, but their actual scientific definition, there's a subtle difference between the two. Let's take an example of a trip to the store 3 kilometers away. The entire trip takes 30 minutes. Your average speed is equal to the total distance traveled divided by the elapsed time. So in this case, our total distance is 6 kilometers, and it took us 30 minutes to cover that distance. This gives us an average speed of 0.2 kilometers per minute, or 12 kilometers per hour. Since we use the total distance traveled, there is no direction indicated in this particular description. This makes speed a scalar quantity. Physicists seldom use speed in their measurements. Instead, they focus more on velocity. Average velocity is defined as displacement, or change in position, divided by the time of travel. Since displacement is included in the definition, it indicates that velocity is a vector quantity, and includes both magnitude and direction in its description. Delta x is the displacement. Delta t indicates the change in time. In our example, hopefully what we notice is that we end up in the same place in which we started. This makes our displacement equal to 0. Since our displacement is 0, our average velocity is 0 as well. The idea that you can travel for 30 minutes and have an average velocity of 0 is one that tends to make you really kind of stop and think. But if we define displacement as our change in position, over that entire trip we haven't changed position. We've ended up in the same places where we started. So our position change is 0. Our displacement is 0. Therefore, our average velocity must be 0 as well. So let's say that we are just going to the store from our house. Velocity is the change in displacement over time. Since we are traveling 3 kilometers in the positive direction, our displacement is positive 3 kilometers. It takes us 15 minutes to make that trip, so positive 3 kilometers divided by 15 minutes gives us a velocity of 0.2 kilometers per minute. When we look at the units in our answer, we have kilometers per minute. This is referring to how many kilometers we are covering in 1 minute. So when we say per minute, we mean in 1 minute. Really, that's a fine way to describe that motion, but what we will find later on is that it is often really important to convert our units into standard units of measurement. In the case of an object's velocity, the standard unit is meters per second. So what we want to do is convert our kilometers per minute into meters per second. We do this with what is known as a conversion factor. This is simply two measures of the same thing compared to each other. For example, you probably know that there are 60 seconds in 1 minute. 60 seconds of time is actually equal to 1 minute of time. So if we set these values up as a fraction and multiply by something, then we are really just multiplying by 1, which is totally legal in the math world. The way in which we set the fraction doesn't matter. We can put the seconds on the top or the bottom. In this case, we have minutes in the denominator of our expression, and we want to get rid of that and replace it with seconds. So it is in our best interest to use the factor with 1 minute on top and 60 seconds on the bottom. This way, the minutes cancel out of our expression, and we are left with seconds in the denominator. We can do the same thing with our kilometers. Kilo means 1,000. So if we have 1 kilometer, we have 1,000 meters. This can be set up as a conversion factor with kilometers in the denominator, so it cancels our original kilometers, leaving meters in the top. To solve this then, we simply multiply everything in the numerator and divide by everything in the denominator. In the end, we get positive 3.3 meters per second. So speed and velocity really are quite different. Speed is a scalar quantity and is found by taking the total distance traveled divided by the time it takes to travel. Velocity, on the other hand, is the displacement over time, and as such is a vector quantity that must include direction.